All right, so welcome to lesson 2.1, which is functions, domain, and range. So we're going to talk a little bit about what a function is. So a function is, think back to like middle school when you had like an input and an output, and then you had a rule like y equals 2x plus 3. And then there's some inputs that you either are given or you can test out. So let's just say 0, 1, 2. And then you take each of these numbers and plug it in, like sub it in for x. So here I'm going to plug in 0. So 2 times 0 plus 3. And that's going to be our answer, which is just going to be 3. And then I plug in 1 here for x. So 2 times 1 plus 3. 2 times 1 is 2 plus 3 is equal to 5. Cool. And then we do the same thing. 2 times 2 plus 3. And 2 times 2 is 4 plus 3 is 7. Okay. So that's our, basically a function is anything that has like an input, output, and a rule. It's like a find my rule kind of thing. Other names for input and output are domain is my input, and range is my output or my y. And think of a function as a machine that follows some sort of a rule or a recipe. So over here, our input is 2. So we're taking 2, and wherever we see an x, we're plugging in a 2 here. We're plugging in a 2 here. So f of 2 is going to equal, right? It's 2. And then instead of our x, we're going to plug in the input, which is 2. We're going to raise that to the third power, right? So all I'm doing is I'm following what my rule is saying. And then I'm adding my x again is 2. So I'll put 2 here divided by 3. And then this is something that I can very well put into a calculator if I'm doing this by hand to practice for the SAT. 2 to the third power is 2 times 2 times 2, which is 8 times 2 is 16, plus 2 is equal to 18. So I have 18 divided by 3, and 18 divided by 3 is 6. So my output, or my f of 2, is equal to 6 is my answer. All right, awesome. So for the second problem, we now have a new rule, g of x, and it's equal to 4x plus sine of x. So we can assume that this is 30 degrees. It doesn't have us say anything about radians or anything else like that. So I could do 4 times 30 plus the sine of 30. Sorry for my handwriting. So 4 times 30 is equal to 120. And the sine of 30, let me just show you real quick on the calculator. You do need to do something before you start putting in sine of 30, and you need to hit the mode button. So mode is right next to the second, and we have to change our function into degrees. Hit enter. And now I can quit out of this and type in sine of 30, hit enter, and I get 0.5. So 120 plus 0.5 is 120.5. So that's our final answer. You could say 120 and a half, same thing. If you just plugged in the whole thing, so 4 times 30 plus sine of 30, that should also give you the 120.5. Cool. All right. I do want to show you something else here. I want to show you that you can use the store button. So 30 above the on button is a store button. Into x, hit enter, and now you can plug in our original rule, which is 4x plus sine of x. So 4x, and now x is 30 plus sine of x, and I hit enter and I get 120.5. So either way I do it, I just showed you 3 different ways to figure out our answer for sine of 30 plus 4 times 30. All right, so domain, like we said, is all possible x values. So I want to refresh your memory about what that means. So here's our x, here's our y. So I'm going to go ahead and find out what is the domain for this function right here. So the first thing we want to do is we want to graph it. So let's go to our calculator. Let's go to y equals, delete what's there, and let's type in our function, right? So our function is square root of x minus 2. So let me put that in. So square root second x squared, and I'm going to do x minus 2. And now I'm going to hit graph. So my graph is going to look a little weird because it's not zoomed properly. So let's just put it back to default zoom. and 6 is standard. So I'm going to press zoom 6. And now it's going to bring me back to negative 10 on the left, negative 10 on the right, negative 10 down, positive 10 up. So negative 10 on the left, positive 10 on the right, negative 10 on the bottom, positive 10 on the right, on the top. So now I can see it starts at 2. So let's go second graph. Let's look across from 2 and we see 0. You'll see that? So across from 2 is 0. So let's go ahead and sketch this. 1, 2. And then the graph looks something like this, right? If I want to be a little bit more exact, I can see 3, 1. So 3, 3, and then I can go up to 1, and I can put my dot here. And I have 2 points, and I think I saw one more point. Was it 6, 2? Cool. So 6, 2 is going to be my last point, but I have enough right now to sketch. So what is my domain, right? My domain is what all the values of x can be. So what you do is you take a ruler, like pretend that this line right here is my ruler, and you scan it from left to right, and you see what is the first point that you get to the graph, where the graph is. So if I take this and I move it, it's not touching the graph, it's not touching the graph, right? It's not touching the graph until I get to 2. So x can be any number that's greater than or equal to 2 is going to be my domain, right? X is any number that's greater than or equal to 2 is going to be what my domain is. The domain is equal to that. All right, pretty good. So now I'm going to do the same thing, and I'm going to do my y values. So range is y. So these are my y values. So I'm going to go back to my calculator. Let's clear this right here. And let's type in the function, right? So let's clear what's here and do 1 over x. So alpha y equals option number 1. Let's put our 1 on the top, our x on the bottom. And now I'm going to hit graph. And we're looking for what all the values of y can be. So, okay, see what happens here? And the graph does something weird. Okay. So what does that mean, right? If I were to sketch this, I'm going to draw my x. I'm going to draw my y. Oh, I said x and y. X first and then y. Cool. And the graph looks something like this. Like that, like that. All right. So when I'm looking for range, I'm going to take my ruler. Let me make this in a different color. I'm going to take my ruler and I'm going to put it like this, horizontally, okay? And I'm going to scan. So when I scan, you can see this line right here, right? It crosses it, right? Because this is going down. So if I scan it from bottom to top, it's going to hit, it's going to hit, it's going to hit. The only value that it's not going to hit at is right here, at this point right here. That means that y can be anything except for 0, literally. So the range is that the y can be any number except for 0. And we can prove that by going to the table. So second graph. And we can see what happens here, right? Like look at the right. So my y is 1, it's 1/2. Cool. And then if I were to go up, I can see it can be -1, goes -1/2, so on and so forth, right? So it continues, but the only number that it cannot be is 0, because across from 0 there's an error. So y can be anything except for 0 is my answer for the range. All right, so I want to ask you to, if you can, to stop the video and try this question, this example on your own, and then play the video and check your answer. Okay, so now that we're back and you've tried this, let's go ahead and do this. So f of 0, that means that wherever there is a x, I'm going to put in a number of 0 squared plus 4. So now I'm going to solve this. So 0 squared is 0 times -1 is still 0 plus 4 is equal to 4. So my range, my output is 4 for f of 0. All right. Then it says, what is the domain and range of f of x? So I'm going to go to my calculator. Let's type in my original function. So let's clear what's there. And it's negative, not minus, right? X squared plus 4. And I'm going to hit graph. So let's see what we get. Okay, that makes sense. So that's a negative x squared graph, and it's plus 4. So let's look at our domain, right? Remember, our domain is from left to right. So if I were to sketch this graph over here, I have something that looks like this, and this number here is 4. All right, so remember, when I'm doing domain, I'm putting my ruler like this, and as you can tell, like over here, right, this keeps on going, so it's going to hit. There's no values of x that cannot be of number, so all of this is included. Cool. So the domain is going to be all real numbers. That's a symbol for all reals. Or you could say from negative infinity to positive infinity. All right, so that's our domain. Now our range is our R. That's going to be, if I were to go ahead and do this a little bit differently. Okay, let's see if I can get that out of here. Get it out of here. There we go. Let's go here. Let's go here. Let's go here. Take this out just so it's not confusing. Okay, so this number again is 4, right? So for our range, we're going to go ahead and put our ruler. Let me change colors here. So I'm going to put my ruler like this horizontally, and I can see that since my arrow goes there, it means that it's going to touch. So y can be any negative number. It can be 0, right? If I put my dotted line here, if I put my ruler here, that's okay, that's valid. At 4 is where it stops. It cannot be 5 or 6 or 7 or 4, even 4.5. So our range is going to be, y is going to be any number that's less than or equal to 4, right? It can equal 4, so there's my answer. If I wanted to write it with, this is called interval notation. If I want to write it like that, I could put 4 or bigger. Okay, brackets around the 4. All right, pretty cool. So why should we care? There's some real life applications. Functions are definitely everywhere. Spotify uses it. You can map songs to artists. So if you have like the songs, you have artists here. So you could have like Drake, what are his, the songs that matches to him. Google uses it for mapping clicks to ads to figure out what ads you actually click on, and then they'll give you more of those. All programming has to deal with functions. So these are the basics of domain and range in functions. All right, good job.